to all joining us today. My name is Adele Krach and I'm from Food Focus, and I want to thank the SASDT for selecting us to present this webinar. The South African Society of Dairy Technology is an active society whose primary objective is to promote and encourage technology and scientific advancement amongst their members, who are the key role players in our national dairy industry. With presentations like today, they communicate new trends and updates on technical issues of benefit to the local dairy industry. PhD and Dan Link are the sponsors for this SASDT webinar. The webinar will be recorded and the slides will also be available with the recording on the Food Focus website. We have a very interesting topic today. Today we're going to speak about Lactoperoxidase, a natural enzymatic system to protect dairy products against microbial spoilage. BIENCA is a Belgian company that develops and provides innovative and by nature inspired solutions for the microbial safety of food products. Their range, based on Lactoperoxidase, which is an enzyme native to milk, help to stabilize the microbiota in food systems. During this webinar, we will present results of different tests that show the efficiency of CI in dairy systems. Now I would like to present you to introduce you to your presenter. Your presenter on this topic today is Alma Flores González. Alma studied food chemistry at the National Autonomous University of Mexico and has a European Master's in Food Science Technology and Nutrition at Dublin Institute of Technology. She has 15 years of experience in the food industry, focused on product development and quality. Alma joined BIENCA in 2021, where she is the Quality and R&D Manager. It is a pleasure to now hand you over to Alma for her presentation. Alma, we're really looking forward to this and can't wait to hear what you have to say about this very interesting topic.
Thank you, Adele. Thank you to the organizers for having me here. So today I will speak to you about the Lactoperoxidase system. And let's go for it. First of all, allow me to briefly present our company. We are BIENCA, a Belgian company that develops and provides innovative and by nature inspired solutions for microbial safety of food products. We have partners all over the world. Our partner in South Africa is Danlink, so thank you very much for sponsoring this together with PhD. Let's start speaking about undesired microbial growth. As you may have experienced already, some of these microorganisms cause undesired effects, such as acidification, change of texture, gas development, or production of toxins. And all these metabolites or these effects will cause that our food is not good anymore. We can prevent that by physical treatment, such as pasteurization or high pressure, by adding chemical additives like sorbates and benzoates, organic acids, or protection based on natural systems such as ours. We do that via a lactoperoxidase system under the brand of CI, which is a processing aid, so it's label friendly and it's an alternative to chemical preservatives. But what is lactoperoxidase? Lactoperoxidase is an enzymatic system that is present in milk, tears, saliva, and it's a host defense mechanism. What happens is that this system creates an unstable molecule that attaches itself to the cell wall, and by doing that, it will inhibit or block the metabolitic pathways of the cell. In that way, Depending on the type of cell and on the concentration of the lactoperoxidase system, it can act as bacteriostatic or bactericidal. In this graph, you can see different concentration of the lactoperoxidase system, and we see that there are different velocities of reaction and intensities of the reaction. The reaction lasts for a short period of time, and that is why this is a processing age. The system has a wide range of activity. However, it has the most effect with bacteria. And we will speak about applications areas. Since we have the honor to speaking with you, we will focus on dairy applications. We have a wide experience of dairy application. Also, this system is extracted from milk, so that is, it works. Let's start with fresh cheeses, and specifically with mozzarella. In the process of production of mozzarella, the lactoperoxidase system can be added at different stages. The system needs water to be homogenized and to travel towards the cells that it wants to attack. So you can put it in the coagulation tank, you can put it in the cooling or in the packing water. And that is indicated with the green blocks. We have made different tests in the laboratory. For example, this is one with Pseudomonas fluorescens, in which we have inoculated these microorganisms in the water of the mozzarella. When we do not add lactoperoxidase, which is the lines that are broken, we can see that the Pseudomonas fluorescens starts growing. Whereas when we add the lactoperoxidase system, it will inhibit its growth and it will actually be non-detectable. So it's quite good to prevent Pseudomonas. In a similar fashion, Listeria monocytogenes, when we inoculate it into our mozzarella in brine, the Listeria starts growing. Whereas when we add lactoperoxidase, it will stay stable and eventually it will be non-detectable. So this is a proof that the lactoperoxidase system, it's an extra hurdle in the food safety management. Due to the control of the microorganisms in the mozzarella, we can see that when we have mozzarella without the lactoperoxidase system, which is the red column, it will stay acceptable until 20 days. Whereas when we add some lactoperoxidase, it will stay conform for a longer period, in this case, more than 1 month. Mozzarella is not the only example. It has also been used in cottage cheese. Again, depending on the process, it can be added at different stages in the creamer or in the cream dressing, or yeah, it's dependent on the process of everyone. Again, an experiment in which lactoperoxidase was added in the dressing before being mixed with the core grains. The cottage cheese was stored at 7 Celsius, and we had control, so no lactoperoxidase and different levels of lactoperoxidase. When we see the total bacteria in the cottage cheese, which is the upper graphic, and you see the uncontinuous line, that is the control, the bacteria don't have anything to stop, and so they will grow. Whereas when we have lactoperoxidase, the quality will remain stable for a longer time. The pH confirms what we just said now. When we don't have lactoperoxidase, the pH will decrease much faster than when we have the lactoperoxidase, which is the triangles, where the pH remains stable for a long period of time. Another example is Queso Fresco. In this case, is Queso Fresco Burgos type. We partner with the University of Burgos to make a pilot test where we produce Burgos cheese, and we added the lactoperoxidase system after the pasteurization and standardization. Then the cheese was produced, and we did counts of the first graphic is Enterobacteria, and the second yeast and molds. For Enterobacteria, we can see that with the addition of 400 parts per million of the lactoperoxidase system, they just didn't grow. Whereas for the control, you can see that they eventually grow like, like the microorganisms tend to do. For yeast and molds, we observe something similar. The control had yeast and molds growing, whereas at 400 parts per million of the lactoperoxidase system, it remained stable. The system can be used in all sorts of dairy applications. We will speak now of dairy beverages. So in this first experiment, the lactoperoxidase was added in raw milk, 300 parts per million. And then it was allowed to react for 8 hours. Then it was pasteurized and stored at 12 Celsius. As you can see in the graphic, the samples with lactoperoxidase, which are the solid lines, have lower cell counts than the control. And here we're speaking of aerobic and anaerobic cell count. But in general, you can see that the solid lines are decreasing, whereas the control starts growing. We can also add the lactoperoxidase system after the pasteurization, which is the case in this graphic. And you also see that the control sample had the psychotropic counts going up, whereas the sample with 150 and 300 parts per million remain rather stable for 9 or 10 days. So and overall, it has lower counts than the control. Once again, for Listeria monocytogenes, in this case, it was inoculated in UHT milk. One sample had lactoperoxidase at 100 parts per million, the other at 300, and the other was the control. We can see that depending on the concentration, Listeria remains stable, so in the same amounts, or eventually it is inhibited at 300 parts per million. Whereas in the control, there is nothing to stop this bacteria, and it just keeps growing. Another pathogen, E. coli O157H7, we observed something similar, where the control had a growth of this pathogen, whereas at 300 parts per million, the counts remain stable. Another matrix that we have tested on is liquid ice cream mix. This is ideal to make the production of ice cream more efficient. Again, it can be used in different stages depending on the process that it's being used. Here we have ice cream mix treated with 100 parts per million of the lactoperoxidase system. And we observed that the total psychotropic bacteria was much more stable with the samples containing the lactoperoxidase system. whereas in the control, it started growing after day 10. In terms of the organoleptic aspect, you can see that in the table below. The samples containing the lactoperoxidase system, they remain good for the duration of this experiment, which was 44 days. Whereas the control, which didn't have lactoperoxidase, started going off at around 15-20 days. So by having a longer shelf life, you can have a more efficient production of the ice cream mix. Voilà. The pH evolution is confirming what we just said. The sample that didn't have the lactoperoxidase system, which is the uncontinuous line, the pH decreases without any issues, it just goes down. Whereas with the lactoperoxidase system, it goes much more slowly and it stays much more stable for a longer period of time. And now I will speak about raw milk. We have made lab tests when we add the lactoperoxidase system in raw milk. And then in this case, we kept it at 25 Celsius just to see what happens, and we did different repetitions. In all of these graphics, you can see that the controls, which are in green, had much more higher counts than the systems with lactoperoxidase, which are always in lower counts and rather stable. Of course, this experiment only took 10 hours, just FYI. When we add the lactoperoxidase system before pasteurization, we also see an effect. We have the lactoperoxidase system added in raw milk. We allow it to react for 4 hours, and then we pasteurize 15 seconds at 72 Celsius, and then we store it at 12 Celsius. We have different cell counts. So in the upper graphic, you see the aerobic psychotropic count. And the Blanco had the counts growing after day 2, whereas the control remained stable for 8 to 10 days. In terms of the anaerobic psychotropic count, something similar happened, and the control just had the exponential growth after 2 days, whereas the samples with the lactoperoxidase system remain stable for a longer period of time. If we see the lactic acid bacteria, which is the graphic to the right, a similar behavior where the Blanco, it just grows exponentially, whereas the lactoperoxidase sample has lower counts. We have used the lactoperoxidase system in industrial tests, so let's say in the real life, and here we have the lactoperoxidase system added in at different concentrations. So you see the green graphics at 200, 350, and 500 parts per million. And the yellow ones are the control. So if we see the upper graphic, that is the aerobic psychotropic counts. And we can see that obviously the control has nothing to stop the growth, so it keeps growing. Whereas the samples at 500 parts per million, they remain stable. So that is quite good. For coliforms, we even have a decrease in numbers, whereas the control, it starts growing after some time. In a different industrial test, where the initial raw milk had a rather higher cell count, we see that the control had a very high number, so they stop after day 1. Whereas the samples with the lactoperoxidase has lower cell counts. And then finally, this is a test made for the collection of milk, in which milk was collected and it was followed during 3 days. The samples were stored at 7 Celsius for most of the time. The last 8 hours, it was allowed to go to 16 Celsius. And what I want to show to you is that the samples control, so the blue ones, have the cell counts growing around, they start growing around 1 day, so 24 hours. Whereas the samples containing the lactoperoxidase system remain in the same cell count. And that is my presentation. So I don't know if you have some questions, and I will give the control back to Adele.
Thank you so much, Alma. I really appreciate that. I have not received any questions from the audience at this point. So, Alma, can I ask you to switch your camera on so that the audience can just at least see your face as well?
Of course.
Thank you. Audience, it's now your time to ask any questions on this very interesting additive, I can think is what we call it. In the meantime, while we wait, Alma, thank you so much. Your slides obviously shown that the system works, and it works for the important things in terms of improving shelf life and so on. While I wait to see, hopefully there will be a question. I've got a question that I would like to ask, and that is around when you utilize the product. You've shown the different stages where the product can be added. The product, do you need to mix it in water before you put it into those different stages? Or is it just in powder that gets put into the different stages? How does it work?
The product is a powder. It's a white powder, quite hygroscopic. So you can add it directly and homogenize it, or you can also make a pre-dilution and then add it to the mixture. It dissolves super fast.
Okay, I see Yompi has got a question. Yompi, what I'm going to do is I'm going to unmute you, and then you can ask the question directly to Alma. I just want to find you on the delegate list. Where are you? There you are. Yompi, you are unmuted.
Okay, Alma, thank you for a good presentation. I think this product is truly exciting. As we mentioned it in the past, it's not new in its totality, but the wonder of this is if you use it in under control conditions, you have huge benefits in respect of milk and other dairy products. That's a fact. Typically, you move from the premise that this product is very suitable to be used under hygienic conditions. If you could perhaps just explain, you can't make something bad good with this product. And that is one thing. And the overexposure of a product to, let's say, the LPS system has got some negatives as well. So that's the one part of my question. The other is, now, how permissible is this to be used in dairy? And that is something that we should also talk about, considering the LPS is well recognized by Codex, and it's also well recognized by the International Dairy Federation, and it's well documented in its totality again. So why is it so that we are not using it? Two angles on it. If it's in raw milk, you can't really consider this to be a processing aid. Raw milk that is now still destined to go to the factory environment. But when you then use it, subsequently use it in, let's say, the liquid that your mozzarella balls will lie in or whatever, that's a different ballgame. So there we talk about possibly a processing aid and not a preservative. So if you could just touch on these subjects that I've just I've thrown you a curveball or two, and talk about those ones.
Yeah, I think there are different topics, so I will try to follow them all. Indeed, lactoperoxidase system is not going to make something bad good. It's not going to make a miracle, let's say. It's going to stabilize the initial quality, so you cannot adulterate, and that is very important. It cannot be used to adulterate or to cheat somebody. It is going to keep the initial quality of the milk. The other part is about the Codex Alimentarius. Indeed, this is listed in the IPA list, so the processing aid list of the Codex Alimentarius. As you mentioned, Jumpy, this is not something new, but in the past, I think people were less concerned about chemical preservatives or chemical situations. And now it is the moment where the consumer is more aware of the effects that this may have. Also in terms of taste, they are aware of what a product with or without preservatives tastes like, and they want a better quality. And that is why we think we are relevant at this moment. The other point that you mentioned, let me think. So it was Codex, it was about excess of the lactoperoxidase system is also not ideal, indeed, because it is peroxidase, so yeah.
Does that answer all your questions for you?
Yeah, just the last one is that when you use this product, and I think you were nearly there, Alma, is that what kind of residue do you find in your final product when you use a LPS system, seeing that we operate in an environment where people are very sensitive to chemical residues in products and so forth. So that's what I wanted to aim at as a last question.
Okay, so we are talking...
Alma, can I jump in there? What I also want to know, added to that question is, are you must then also put it on your ingredients list, because I mean it's not just milk anymore, there's now things added. So how is it added to the ingredients list?
Well, as Jumpy mentioned, when you add it to milk or to a product that is going to be transformed, then it is a processing aid, and processing aids don't need to be labeled. Okay. We are talking about an enzymatic system, so it's proteins at parts per million. And after they have their activity, as I show in the first graphic, they just inactivate. So they don't have a function anymore.
Okay. So, ladies and gentlemen, the slides is also very explanatory in terms of the technical side of what it does. I've got another question here for you. How cost effective is the use of an LPS system? Thank you.
The cost in use always depending on the type of product and how much spoilage that we have, and what is the target that we want to reach. Is it stability? Is it food safety, stabilization during whole period, or is it extension of shelf life? That's one thing. The other thing is that we are talking about ppms. The cost in use, of course, is an extra cost that you have to put into your recipe. On the other hand, you are going to gain a lot of positive effects. On one hand, depending on seasonings, depending on production processes, you can save money in batch-wise production, because you have the possibility to increase your batch as such. On the other hand, also your logistics, you will gain money. You will not have or limited recalls. The risk of having recalls is limited. Yeah. And if you are taking all those types together, and now I'm not only talking technical, but also a little bit economically. Some of our customers in the world made that calculation because they had all the types of costs that they had to put into the product. And finally, at the beginning of the recipe, okay, the cost of the recipe as such is increasing. But if you're looking to all the advantages next to that, they have an improvement of a couple of euro cents a kilo on the end product.
Okay. Okay.
But that is all depending from process to process. How is cost calculation done? How is the organization built up? And how is the market? And how is the structure of the delivery to the markets?
Yes. Yeah. No, definitely. I think, like you also say, is sometimes if it comes to protecting your brand, preventing recalls and all of that, that's many a times cost that's not taken in account. But this will definitely help for that. So that's good. Okay, so thank you so much for that answer, Rudolf. I appreciate that. Then I've got another question here. Can the LPS be used effectively in the manufacturing of hard cheese on its own without the use of other preservatives?
Yes, it can be added in the manufacturing of hard cheese. I think we have a couple of clients, well, that have done that. And then the other question was?
No, that was the one question. So it can be. Okay. One more question. The advantages of LPS in respect of UHT milk flocculation. That is from Yompi.
Yeah. I don't know. I will have to check that.
That is a clear answer, Yompi. So we can most probably afterwards, put you into contact with Alma, and then you'll be able to get that answer. Then I've got another question here. It is confirmed that we cannot use it in raw milk as a processing aid. Is that confirmed, that we cannot use it in raw milk as a processing aid?
Yes, because then it's not raw milk anymore.
Okay. I hope that answers your question on that side, Barry. Then I've got another question. Will the LPS also reduce the activity of the enzymes produced by let me just get this. Is it psychotropic?
Psychotropic?
Yes, over the shelf of UHT products.
It will for sure affect them because, as I mentioned, these couples with their cell wall and it affects their metabolism. So they are distracted and then they will stop doing whatever they are doing because they are just trying to survive.
Yes, yes.
Yeah.
Okay, it doesn't seem like there's any other questions coming from the audience. But what I will do is, Alma, I will, provide you with these questions as well. And then as the audience, you will receive the information on the recording as well as in the PDF document that we will have with the download. And I'm sure that you can reach out to Alma if you've got any further questions. So with that, I would like to thank you, Alma, for your time. And
thank you.
You absolutely, and you must have a great day. I would like to thank the SASDT and their sponsors, PhD and DanLink Ingredients. The recording, like I said, and the slides will be posted on our website before the end of the week. You will also receive an automatic generated certificate from the GoToWebinar platform for your attendance today. Please note that you need to download and save your certificate, as this is a once-off done from the system, and it's unfortunately not possible for Food Focus to provide you with a copy of your certificate should you lose that email or not download your certificate. To make sure you do not miss any of the webinars we host, please make sure to go to our website foodfocus.co.za and sign in to receive our newsletter. You can also be on the lookout for any of our social posts on Twitter, Facebook, and LinkedIn. and we will appreciate if you follow us on these social platforms. For your interest, the DSA is hosting a webinar on the 26th of July, and the topic is the key to effective sampling of milk and dairy products in the trade. Make sure to register for this webinar. The link is on our website. Please do us a favor, and as soon as the webinar is closed, there is a short survey. Please be so kind to answer the questions on this survey. We will really appreciate your feedback. And with that, I want to say thank you so much once again for your time. Have a great afternoon until the next webinar. Goodbye, everybody.